Hello everyone. This video is I'm going to talk about there's a homework problem. As a homework problem, and it's I think it can classify as an inelastic collision. Okay, let's look at this problem. Because this problem maybe some student will some will feel some confused, especially the calculation process or calculation procedure. Okay, so this problem is okay, a car is moving at speed v, okay, and v is given v, okay, undergoes one-dimensional collision with an identical car. Okay, that means identical car. That's just tell you, okay, these two cars, they have the same mass, and this car initially is at rest. Okay, and it says the collision is neither elastic or fully inelastic. I'll say it says 7/32 of the initial kinetic energy is lost by the velocity of the two cars after the collision. Okay, so this is the collision problem. Okay, so it's collision problem. So let's say in the collision problem, what's our analysis tool? Let's open. I forgot. I forgot opening advance. Okay. Okay, let's see. It's for the collision problem. What's our analysis tool? Okay, because in the collision problem, yeah, in the collision problem, always treat the system is isolated. Okay, so the collision problem. First of all, system is isolated. So the first analyze tool we have is momentum conservation. Conservation. That's our first tool. Okay, we must use it. And the second one is also called kinetic energy conservation. Kinetic energy, energy conservation. Okay, this is the second two, and the other two is okay. V2 minus V1 minus V2 equal to V2 prime minus V1 prime. But apparently we cannot use this time because this equation is for elastic collision. This is for elastic collision. And for this problem, the problem just say it's not elastic collision. So this equation we cannot use. So we only have to use these two tool. Okay, we have no choice. And it said that in it. So okay, so first of all, the momentum conservations. Okay, so let's use the momentum conservation to list the first equation. Momentum conservation, okay, that means the initial, before collision, the momentum is equal to the momentum after the collision, right? Okay, so initially, if I remember correctly, one car is moving with the velocity v, and the other car is at rest. So before the collision, what's the total momentum of the system? Okay, it's one. Let's assume the mass of the car is m, and the velocity v, and the other car, identical car, right? So has the same mass m, but initially at a rest. Okay, so after collision, what's the velocity of these two cars? We don't know. Okay, that's one we want to figure out. So I say it's v1 prime plus v2 prime. Okay, so let's say, okay, so I should say v1 is v before collision. V1 is v, and v2 is 0. Okay, so and because the mass is the same. Oh, sorry, this is, yeah, because the mass is all the same, so we will get the first equation, v equal to v1 prime plus v2 prime. Okay, the second tool we have the energy conservation, but right now we reduce to kinetic energy conservation because we assume it's a 1D collision problem, and 1D problem, there is no high difference in this system. Okay, no spring in the system, so we don't have any potential energy, so we can get the potential energy off. Kick the potential energy off, so we only have the kinetic energy in that equation. Okay, so the kinetic energy, the The problem says, or the problem say, the 7/32 of initial kinetic energy is lost. Okay, so that means there will be 25/32 of kinetic energy after the collision. Yeah, you understand this point? Yes, 7/32 of the initial kinetic energy is lost, but which equal means 25/32 of initial kinetic energy is preserved after collision. Okay, so let's start from this point. 25/32 of the initial kinetic energy is preserved after collision. Okay, so initial kinetic energy is 1/2 mv squared, right? So let's we'll use kinetic energy conservation. The kinetic energy conservation. So it says 25/32, the initial kinetic energy. So 1/2 mv squared is preserved. Okay, so it's preserved is equal to 1 mv1 prime square plus 1/2 v2 prime square. Okay, so and then what will we get? Okay, because everyone has m, so yeah, it should be m here. Okay, sorry, I should write the m here. I always write too fast. 1/2 m. Okay, that's divided m. Oh, okay. So what will we left? Okay, so this will be 25/64 v squared equal to sorry. See, we also can kill the 1/2 off because everyone has 1/2. Everyone has 1/2. So okay, we have 32 v squared equal to v1 prime square plus v2 prime square. Okay, so yeah, right now we got the two unknowns, v1 prime, v2 prime is two unknowns and two equations. So that tells us we have the one solution. Yeah, solve this problem is kind of, I have some algebra work. Yeah, some algebra work. Okay, so we still can do it. Okay, let's start. Let's show the calculation process. Okay, so I want to replace the v2 prime off. So like I said, so from this, suppose this is 1, this is 2. Okay, so from 1, we have v2 primes equal to v minus v1 prime. Okay, when you substitute and put them in 2, okay, so what would we have? Okay, so what we had, 25/32 v squared equal to v1 prime square and doesn't change, and the v2 prime square will change it, so it's become v minus v1 prime square. Okay, so actually it's not that difficult to solve. Okay, so 25/32 v squared is equal to v1 prime square plus v square minus 2v v1 prime plus v1 prime square. Okay. And then we do some algebra, make it a more compact form. So we'll have 2 v1 prime square plus, okay, let's see, it's minus 2 v1 prime. And okay, so the final one is plus 7/32 v square is equal to 0. Okay, and do a little further. Okay, so we will have v1 prime square minus v1 prime and plus 7/64 v square equal to 0. Okay, we get the quadratic equation. How to solve the quadratic equation? We remember that. How to solve a quadratic equation? Yeah, how to solve this quadratic equation? Yeah, I hope everyone learned this before. Yeah, that's how you solve the quadratic equation, right? We have quadratic equation. Right now, our Lx is just the v1 prime. Yeah, that's our x right now. So how to solve the v1 prime? Okay, so going further, also well, v1 prime is equal to 2 times 1. Let me check. Did I calculate right? Okay, right. Okay, 2.1 and it's v plus minus negative v squared minus 4 times 1 times 7 over 64 v squared, right? Or 2 times a minus b plus minus b squared minus 4 times a times c. Okay, that's right. Okay, so it's not really that difficult, right? So this will become v squared minus 16 7 v squared. Okay, and the number is not that bad. Okay, so 2 v plus minus it's 916 v squared. So I think we get a solution. So that's our solution is 3 over 4 v. So we have two solutions. One solution is let us see. One solution is for 1 plus. So it's one solution is 7 over 8 v. The other solution is 1 over 8 v. That's our v1 prime. Okay. So, and we previously will get a solution, right? v2 prime is equal to v minus v1 prime. Okay, so we use this equation, v2 prime equal to v minus v1 prime. So, if v1 prime is 7 over 8v, so our v2 prime is 1 over 8v. Okay, if the v1 prime is 1 over 8v, so our v2 prime will be 7 over 8v. Okay, so we have two answers. Okay, which answer is more correct? Actually, based on the information of the problem, it's really difficult to judge. So I think we have two answers. Okay, this is v1 prime. Okay, this is v2 prime. v1 v2 prime pair. Yeah, because there's no information for v1 prime. Maybe the right one sounds more reasonable. Okay. Yeah, because a car hit a car at rest, and the car at rest, then the impact car will carry more velocity. This may be more reasonable. Okay, but actually, based on the information problem, you cannot reject the possibility of this one. Yeah. This is more reasonable, but we cannot ignore the possibility of this answer. So I think the both answers are correct because the information of the problem is so few. We really cannot judge anything. Okay, so with this problem, in my opinion, it has two answers. Both answers are correct. Okay, so here's a problem 9.81, right? 9.81. See, 9.81. Yeah, 9.81. So maybe I should use here. No, never mind. Okay, 9.81. Okay, here's the answer. I'll just stop video here and see you in my next video. Bye bye.